Knowing the perfect squares greater than 1, namely 4, 9, 16, and so on, will help you simplify some radical expressions. You can simplify the product of powers that have the same exponent. Similarly, you can simplify the product of radicals that have the same index. For example, on the left, with the same exponent, we have 2 squared times 3 squared, the same exponent of 2. That can be rewritten as the product 2 times 3 squared. Below that, 4 cubed times 5 cubed, a common exponent of 3, can be rewritten as the product 4 times 5 cubed. And on the right, with the same index, we have the square root of 2 times the square root of 3, both with the same index value 2, because they're square roots, can be rewritten as the square root of the product 2 times 3. Below that, the cube root of 4 times the cube root of 5, a common index of 3, can be rewritten as the cube root of the product 4 times 5. Take note, property, combining radical expressions, products. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of the product, a times b. Problem 1. Multiplying radical expressions. Can you simplify the product of the radical expressions? Explain. Part A. The cube root of 6 times the square root of 2. No, the indexes are different. We have a cube root of 6, index of 3, and a square root of 2, index of 2. The property for multiplying radicals does not apply. Part B. How about the cube root of -4 times the cube root of 2? Yes, we can simplify the product. The indexes match. Here we have an index of 3 in both terms. And so multiplying, we find that the cube root of -4 times the cube root of 2 equals the cube root of the product, -4 times 2, which is the cube root of -8, which is -2. Your turn, part A. Can you simplify the 4th root of 7 times the 5th root of 7? Explain. And part B. Can you simplify the 5th root of -5 times the 5th root of -2? Explain.